Good evening, ladies and gentlemen. Sit back, relax, and enjoy some introduction to lines and angles, specifically parallel lines, and what they mean when you got a transversal cutting through them. So we're going to break this down into three separate parts to start off with. We're going to talk about the identification of lines and angles. We're going to then talk about what happens with those angle pairs when and if they deal with parallel lines. And then finally, we're going to kind of flip the table, and instead of talking about what happens to the angles when they're parallel lines, we're going to talk about what the angles need to be in order to prove they're parallel lines. It's actually pretty simple once you get the hang of it. We're going to be relying a little bit heavier on our algebra than we have in the past once we get going. So let's talk about it. So the first thing we really need to talk about is the word transversal. Now, a transversal, spelled like this, Transversal, is any line that touches two or more lines at specific points. So it's got to be a straight line through two other straight lines. Or at least it's got to be a straight line through two other lines and only touch in one place. So here I'm going to label these lines A, B, and C. Okay, so C is the transversal because as you can see, it cuts through there and there. And so when that happens, you'll notice that at each point of intersection, you get four specific angles. Okay, so what we're going to do is if I can do this right, we are going to blow this up a little bit and get you a little bit of a closer look at those angles. There we go. Now I'm going to label these angles 1, 2, 3, 4, 5, 6, and that's right, 7 and 8. So when we're looking at these, we're going to be talking about four major types of angles. And we're going to be flipping back and forth a little bit. And those major types of angles are corresponding, alternate interior, same side interior, and finally we're going to be talking about alternate exterior. Now once we get into parallel lines, these pairs have specific properties, but right now all we want to do is identify them. So corresponding means that they're in the same place. Okay? It means that the lines, so here, if we look at this group right here, we notice that the lines, we can say this is top left, top right, bottom left, erase that, bottom left, and bottom right. So if we do that on this group right here now, you'll notice that each angle matches up with another one. So here we have top left, top right, bottom left, bottom right. Now these are arbitrary. You can name them anything you want: blue, green, red, yellow. But So when we're talking about corresponding angles, what we're going to do is we're going to match up the two top lefts, the two top rights, the two bottom lefts, and the two bottom rights. So those are going to be our corresponding pairs. So we have angle 1 and angle 5. We have angle 2 and angle 6. We have angle 3 and angle 7. And finally we have angle 4 and angle 8. Okay, so those are our 4 sets of corresponding pairs. As you can see here, each one of those is top left to top left, top right to top right, bottom left to bottom left, and bottom right to bottom right. Okay, so that's what corresponding means, same area. Now, if you really wanted to look at kind of what was the cornerstone of modern geography, geometry, it really would be those corresponding angles, but we'll get to that a little bit later. So what we're going to talk about next, as you can see, is alternate interior angles. Okay, that's the one in the red. So alternate interior angles. Whenever we have these two lines in a transversal, the transversal is going to have an area where it's already hit one line but hasn't hit the next line. That's considered the interior. Now in the picture I just drew, it's up and down. It can also be side to side. It's important to understand that when we're talking about the interior, we are talking about in between the two lines that the transversal hit. Next, what we want to do is we're talking about alternate interior. So this is the transversal right here. I'm going to highlight it in red. And you have two choices. Things are either on the same side, like 3 and 5, or they're on opposite sides, 3 and 6, 4 and 5. Now look over here. We have both alternate interior and same side interior. So alternate interior is going to be what happens right here when they're on opposite sides, 3 and 6, 4 and 5. Okay, so thank you. My daughter thinks this is a really good 5. Why? Because it doesn't look like an S. So, our alternate interior pairs, notice color-coded, because color coding is awesome, are, and I just totally forgot what they were, 3 and 6, 4 and 5. Angle 3 and angle 6, angle 4 and angle 5. So those are alternate interior ones. Now, if we look back here, we can see that same side interior, again, remember the interior is this right here in between the two lines. So our same side interiors would be 3 and 5, 4 and 6. Let's go put those over here. Angle 3, oops, wrong pen. I was using my marker. There we go. Angle 3. And angle 5, and angle 4 and angle 6. Thank you, sweetie. Okay, so those are same side interiors. See, same side on the interior. So that leaves us with alternate exterior, which I believe I did in green, right? Yep, kind of a limeish green. Okay, so now we're talking exterior. So it makes sense that this is the interior here, that this area outside is going to be the exterior. Okay?
It's like a green or ocean.
Okay, so we're talking about 4 groupings here, okay, or 4 angles, 1, 2, 7, and 8. And again, when we talk about alternate, we're talking about how exactly they interact with our transversal. So our transversal, again, is this one right here. Why is that the transversal? Because it's hitting the other two lines at distinct points. So when we're looking at alternate exterior, we're looking at exterior angles that are not adjacent. So if we start with 1, can't be 2 because 2 is adjacent, and it's on the opposite side. So it gives us 1 and 8, and likewise 2 and 7. Okay, so for the rest of this lesson, those are the only 4 relationships that you really need to know. And so the assignment on 3.1 is really just identifying those groups. It talks a little bit about parallel lines and skew lines, but really it's about just identification. Okay, so moving on. So now we're going to start talking about the relationships that these have with each other. Okay, so if I have 2 parallel lines, how do we know they're parallel? Because they got these cute little red arrows. Okay? Okay, can you give some to the bird, please? Okay, so again, I'm just going to write these angles down. We go 1, 2, 3, 4, 5, 6, 7, 8. Now we look back here, and so we're going to keep referring back to this page right here. This is the page that shows all those relationships. So let's start off. We start off with our corresponding angle postulate. Now the corresponding angle postulate is really kind of the cornerstone of modern geometry. And remember, if you are lagging a little bit behind, you want those extra credit points, you can do a research project on Euclid and his postulates. Okay, so corresponding angles. We have 1 and 5, 2 and 6, 3 and 7, 4 and 8. Just like we had back here, see? And it's important to know that when lines are parallel, so if parallel lines, that little slanted 11 means parallel. If parallel lines, then the corresponding angles are congruent. And that really is kind of one of the most crucial things you can learn in geometry this year. If the lines are parallel, corresponding angles are congruent. So that means if we look here, 1 and 5 are going to have the same measurement. 2 and 6, 3 and 7, 4 and 8. Why? Because those 2 lines are parallel. And if you have 2 parallel lines crossed by a transversal, then the resulting angles, the corresponding angles, are congruent. Okay? And that leads us to alternate interior angles. Remember, those were the ones in red. Okay, so let's look first at 3 and 6. So what we notice here is that they're both acute. Okay? And as we look at that, so we're looking at 3 and 6. And the rule is, this is called the alternate interior postulate, and that's alternate interior angles are congruent. If 2 parallel lines are crossed by a transversal, the resulting alternate interior angles are congruent. And let's look at that, because so we have 2 things we need to remember. This right here, if parallel lines, then corresponding angles are congruent. That is a must. Now let's look at 3. What else do we know about 3? Well, check out 2. 3 and 2. So angle 3 is congruent to angle 2 because they're vertical angles. Angle 2 is congruent to angle 6 because they're parallel lines and corresponding angles are congruent. So finally, if 3 is congruent to 2 and 2 is congruent to 6, good old transitive property says that angle 3 is congruent to angle 6. Okay, so that would be true for 3 and 6 and 4 and 5. Those are corresponding. Okay, no, not corresponding, those are alternate interior and therefore congruent. So back here we are, and now let's look at our next grouping, and that is same side interior, so 3 and 5. Well, we can look at 3 and 5 and know right off the bat that 3 and 5 are not, in fact, congruent. One's acute, one's obtuse. Okay, so what do we know? Well, we know that 3 and 7 are congruent. Why? Because they are corresponding angles right here. They're both bottom left. So 3 and 7 are corresponding angles. in two parallel lines crossed by a transversal, and therefore they are congruent. We also know that angle 7 plus angle 5 equals 180 degrees. Since we know that angle 5 and angle 7 equal 180 degrees, and we know that 3 is congruent to 7, we can sit there and go, well, if 3 is congruent to 7, then the measure of angle 3 is equal to the measure of angle 7. The measure of angle 7 plus the measure of angle 5 is 180 degrees. Then we can substitute out and go the measure of angle 3 plus the measure of angle 5 equals 180 degrees. What do we call two angles that add up to 180 degrees? I can't hear you. That's right, supplementary. So we go back here. Corresponding angles. Congruent. Honey, what time is it? You need to finish that apple so you can brush your teeth and get to bed. Alternate interior angles are also congruent. Okay, but you can still brush it without. Same side interior angles. Those are going to be supplementary. And that leaves us with alternate exterior. So alternate exterior, let's look at 1 and 6. Okay, so 1 and 6 is what we're looking at. And do we know any direct relationship between 1 and 6? No, we don't. But we do know that there's a relationship between 1 and 2. Okay? 1 and 8 is what we're looking at. So 1 and 2 doesn't help us. What about 1 and 4? Well, angle 1 is congruent to angle 4 because they're vertical. Vertical angles are congruent. That's the vertical angle theorem. We also know that angle 4 is congruent to angle 8, again, because they're parallel lines. And so that would be parallel lines corresponding angles are congruent. Okay? And if 1 is congruent to 4 and 4 is congruent to 8, cross that off. We get angle 1 is congruent to angle 8, and that is the transitive property of congruence. Okay? So that's true for 2 and 7 as well. 2 is congruent to 3. They're vertical angles. 3 is congruent to 7 because they're parallel lines. So go back here and let's write that down. And those are going to be congruent. So keep in mind, this only happens if they're parallel lines. We can look back here and clearly see that 1 and 8 are not congruent. 3 and 6 are not congruent. 4 and 5 aren't. 2 and 7 are not. Okay? And so this only happens when there are parallel lines. So corresponding angles are congruent when parallel lines. If parallel lines are crossed by a transversal, alternate interior angles are congruent. If two lines are parallel, then same side interior angles are supplementary. If two lines are parallel, then alternate exterior angles are congruent. Okay, so let's look at a problem and application of this. Okay, well, go put it in a baggie and put it in the fridge. You can have it tomorrow. Okay, so let's look at one of the problems you had to do for, and this is going to be under 3.2. So this problem set starts on page 153. Okay, so we're going to do a slightly easy one. Well, let's look at number 8 first, okay? So number 8, we have our lines here. And like I told you, the transversal doesn't have to go up and down. Here it's sideways. Here we have 1, 6, 7, 2, 3, 4, 5, and over here, 51 degrees. So this says identify all the numbered angles that are congruent to the given angle. Justify your answer. What's wrong? That's okay. Okay, so let's look. So first we know vertical angles, okay? So we go angle 7, vertical. Okay, so that's great, but where else? That only gives us one. So let's look back here, and we also note that corresponding angles, alternate interior and alternate exterior, those are all going to be congruent. So let's look back here and go, okay, so this is our angle 51. Interior or exterior? It's interior. So we know that from that point of view, we're going to be dealing with same side or alternate interior angles. Alternate interior angles 4. So we go angle 4, and we say that it's alternate interior. You know, I forgot something very important here. These two lines are parallel, because if not, none of this can be said. And then finally, we have corresponding angles. Because this is going to be top left over here, we look over here, top left, and we go angle 5, corresponding. And that's how we do 8. Now, you were assigned odds, I think. So this is just a freebie. So let's look down now at the algebra portion of it. And let's look at 16, okay? So we're looking at 16. I'm actually just going to erase this page. Yeah.
It's hard. I'm sorry to just
You're fine, honey. Here, go make sure you pull that stuff off and go put it in the trash can. Okay. Toothpaste issues. So, here we have a kind of weird looking triangle. We've got this and that. And here we're being told that these two lines are parallel. Okay, so really what we're looking at is we have this angle right here, 3x minus 10, and this angle right here, which is x plus 40. Now you may sit there and think, well, we didn't go over this, but you know what? We kind of did. Here's what I want to do. I'm going to blow this up. Okay, so now let's look at this, and let's draw these lines out a little bit further. We'll draw that line out, and this line out. Well, now, all of a sudden, if we look at this angle right here, and this angle right here, now we see that this one is bottom left, this one is bottom left, which means they're congruent. So we go back here, and we go, okay, what are congruent angles, or what are corresponding angles? They're congruent. Got my words flipped out there. These are corresponding. They're both bottom left. So they are equal to each other. The measures are equal to each other because the angles are congruent. So if we have 3x minus 10 and x plus 40, we can simply set those equal to each other. 3x minus 10 equals x plus 40. Algebra, subtract x from both sides. We get 2x minus 10 equals 40. We're going to add 10 to both sides. Good old addition property of equality. Get 2x equals 50. Want to divide both sides by 2, and we get x equals 25. So we got x equals 25. Let's just find the value of x, then find the measure of each angle. Well, we know that x equals 25, so all we have to do is plug it back in. Now, if we did this right, we should get the same answer on both sides. 3 times 25 minus 10, and 25 plus 40. So this one's the easier one. We get 65. Here we get 75 minus 10. Not necessarily hard, but we also get 65. So those are the measure of the two angles, and x equals 25. Okay? So what we're doing next, all the others are simply, so what I want you guys to do is if you run into trouble on any of those, I really want you guys to sit there and draw the angles that you're worried about independent of the shape. Okay, mark which lines are parallel, if any. Draw the lines out, and then be able to look back at this diagram right here and this diagram right here and go, okay, what are my corresponding angles? What are my alternate interior angles? What are my alternate exterior angles? And what are my same side interior angles? Good night, sweetie pie. Beautiful. And then we'll go from there, okay? Because once you break that down, then you know what their relationship is. Okay? And that would be, if I was going to give you steps to solve this, it'd be this. Step 1, identify pair and
Contrast.
relationship. No, not compare. Pair, like two things.
Can I leave my door open?
2, no, because then the cats will get out.
Oh.
I know.
Oh,
2,
I have this.
right, yep, right, relationship. As an equation. 3, solve equation. And 4, answer the question. And why I put answer the question is because a lot of times, even though you solve the equation for x or y or w or p or t or whatever it is, that actually won't be what it is. Notice on the last problem we did, it said solve for the variable and then determine the measure of each angle. So it's important that you go back, look at what the question is asking you, and go from there. Okay. So, what we looked at in section 3.2 was this. We said if parallel lines, then we got corresponding angles are congruent. We got alternate interior angles are congruent. We got same side interior angles are supplementary. And we got alternate exterior angles are congruent. So what we're doing in 3.2 is the converse. Now if you go back, if you don't know what a converse is, go back and look at my intro to conditionals. So converse is we're switching the if and the then. So before where we said if two parallel lines are crossed by a transversal, then, and all these things follow. Now what we're going to say is if two lines are crossed by a transversal and corresponding angles are congruent, alternate interior angles are congruent, same side interior angles are supplementary, or alternate exterior angles are congruent, then the two lines are parallel. So before we sat there and we said, if the lines are parallel, then these relationships are going to happen. Now we're sitting there and going, if these relationships occur, then the lines are parallel. Same idea, just kind of looking at it front to back. That's what makes a good definition. So just really quickly want to work through one of these. So what we're going to do is let's look at, actually we'll do two of these, okay? So first things first, let's look at 15. Okay? So we're looking at 15 on page 161. And the problem says find the value of x for which L is parallel to M. Okay, so we have these two lines right here. This is M and L, and then this line right here. So this is M, this is L, this is 3x minus 33, and this is 2x plus 26. Okay, so this is what we're going to do. We don't know whether or not these lines are parallel, okay? But what we're asked to find is for what value of x will these be parallel? So we assume they're parallel, treat them as if they're parallel, solve for x, but instead of then saying because the lines are parallel, x equals this, we say if x equals this, then the lines are parallel. Hopefully that makes sense. If not, come see me. So we look at these and we go, okay, what is our relationship? We have those four basic relationships. We have corresponding, alternate interior, same side interior, and alternate exterior. So what I like to do is I like to sit there, look at the transversal, highlight that. Okay, so this is my transversal right here, and these are my two lines, which I'm trying to determine whether or not they're parallel. So the interior is going to be here. Okay, so right off the bat, that means I can get rid of my two interior lines. Okay? Next, we look at whether they're corresponding or alternate exterior. Okay, so corresponding, if we go, this is top left, top right, bottom left, bottom right. Then over here on this set of angles, this would be top left, top right, bottom left, bottom right. So our two angles are top left and bottom right, not corresponding. So we're going to erase those. And that means we have alternate exterior. Alternate exterior, let's check. Is this on the exterior, 3x minus 33? Yes, it is. So alternate exteriors are on the other side of the transversal and not adjacent. So it's not this angle right here. So it's got to be this angle right here. So they are. And then we look back. And we go all the way back through all the work we did. Look at all that work. And we see alternate exterior angles are congruent, okay? So alternate exterior angles are congruent. And because they're congruent, it means their measures are equal to each other. So you go 3x minus 33 equals 2x plus 26. That's a 26. Straight up algebra, minus 2x minus 2x. We get x minus 33 equals 26. Want to add 33 to both sides. Go to addition property of equality, and we get x equals 59. Okay? So x equals 59. If we went and plugged that back in, we'd get 3 times 59 minus 33, and 2 times 59 plus 26. That would be 118 plus 26, or 144. Okay, over here, we are going to have 177 minus 33, or 144. Because those two match up, we know we did it right. Because they're congruent, which means their angles are equal to each other. The measure of the angles are equal to each other. So that would be number 15, I believe, on page 161. Okay, so now what we're going to do is, what else did I get in? So what I want to do is I want you to look at, I want to do one where they're not congruent. So go back, and we're going to look at the problem we did in class. That's on page 159. It's the problem number 4. So here we were given two lines. Like so. Angle here, 2x plus 9 and 111. So again, I identify the transversal right there. And I look at those two, and after I go through corresponding alternate interior, same side interior, and alternate exterior, I'm going to go, okay, my interior is right here, and they are on the same side of the transversal. So they're going to be same side interior. Look back, same side interior angles are supplementary. So this is what I do. I go, same side angles are supplementary. That means that their sum is 180 degrees. 2x plus 9 plus 111 equals 180. And again, then we just use our prodigious algebra skills, solve that out. 2x plus 120 equals 180. Let's subtract 120 from both sides. Get 2x equals 60. Divide by 2, and we get x equals 30. So x equals 30, let's plug it back in, make sure that works. 111 doesn't change at all. So we have 2x plus 9, plug 30 in there, we go 2, that's a 2, times 30 plus 9, that gives us 60 plus 9, 69, double check, 111 plus 69 equals 180. We got two alternate or same side interior angles. They are indeed supplementary, and that means we did it correctly. As always, if you have any questions, leave them in the commentary. If you need help on specific problems, leave it in the commentary, or go ahead and email me. If you need extra help before school, after school, at lunch, just let me know. Sometimes I'm running in and out. If I know you're coming, I'll make sure I'm there. Have a wonderful evening, everybody, and I will see you tomorrow.